You are standing in the South Pacific Ocean, surrounded by remote, icy, and deep waters. It's 1997, and the U.S. National Oceanic and Atmospheric Administration, or NOAA, has just detected something extraordinary. A sound nicknamed Bloop has been picked up by the Equatorial Pacific Ocean Autonomous Hydrophone Array System designed to monitor undersea seismicity, ice noise, and marine mammal population and migration. This sound is unlike anything heard before. It's an ultra-low frequency, high-amplitude underwater sound that rose in frequency over about 1 minute and was of sufficient amplitude to be heard on multiple sensors at a range of over 5,000 kilometers. You can imagine the curiosity sparked by such a detection. Christopher Fox from NOAA would later describe the sounds as being far more powerful than the calls made by any animal on Earth. The sound source was roughly triangulated to 50 degrees S 100 degrees west away, a remote point in the South Pacific Ocean. As the news of this mysterious sound spreads, speculation begins. Could it be a marine animal, something unknown to us? The audio profile of Bloop does resemble that of a living creature, but the source remains a mystery. Fox's hunch is that the sound is the most likely to come from some sort of animal, because its signature is a rapid variation in frequency, similar to that of sounds known to be made by marine beasts. But how could any animal produce a sound loud enough to be detected by sensors 4,800 kilometers apart? The mystery of Bloop has just begun to unfold, and you are about to dive into the unknown to explore the possibilities and uncover the truth behind this enigmatic sound. You are diving into the unknown, exploring the possibilities behind the Bloop, a sound detected by sensors 4,800 kilometers apart in the South Pacific Ocean. As you delve deeper, you come across Christopher Fox, who in 2001 shared his initial thoughts on the Bloop's possible animal origin. The audio profile of the sound resembles that of a living creature, with a rapid variation in frequency similar to sounds made by marine beasts. However, the loudness of the sound is far more powerful than any animal on Earth, leaving Fox puzzled. In 2002, Fox stated that while the sound's origin was a mystery, it was not man-made, and its signature was unlike anything seen before. The sound rose in frequency over about 1 minute, with an amplitude sufficient to be heard on multiple sensors. As you consider Fox's words, you begin to wonder, could some creature bigger than any whale be lurking in the ocean depths, or perhaps something more efficient at making sound? You are now standing at the edge of the unknown, staring into the dark, icy waters of the South Pacific, where the Bloop was first detected in 1997. The unknown, staring into the dark, icy waters of the South Pacific, where the Bloop was first detected in 1997? You are standing at the edge of a frozen, dark landscape, with the icy waters of the South Pacific Ocean stretching out before you. The year is 1997, and a mysterious sound known as the Bloop has just been detected by the U.S. National Oceanic and Atmospheric Administration, NOAA. As you look out into the distance, you wonder what could be causing this low-frequency rumble, which was loud enough to be heard on multiple sensors over 5,000 kilometers apart. Theories begin to emerge, including the possibility of a massive iceberg, like a 5-3A, which was tracked by scientists in 2008 as it disintegrated near South Georgia Island. Researchers noticed that the spectrogram of the Bloop bears a striking resemblance to those of known ice quakes, which are caused by the fracturing and movement of large ice masses. This new information sparks a flurry of interest as scientists like Christopher Fox from NOAA begin to investigate the possibility that the Bloop is not a biological sound, but rather the result of a non-tectonic cryocism or icequake. You start to consider the idea that the Bloop might not be a creature at all, but rather the sound of ice calving, or the breaking off of large chunks of ice from a glacier. As you ponder this possibility, you can't help but feel a sense of awe at the sheer power and mystery of the natural world, and the idea that there are still so many unanswered questions about the Earth's oceans and the creatures that inhabit them. You are standing on the edge of a remote, icy, and deep ocean in the South Pacific, where the mysterious Bloop sound was detected in 1,997 amperes. You gaze out at the vast expanse of water. You can't help but wonder what could have produced such a powerful low-frequency sound. One possibility is that it wasn't a creature at all, but rather the sound of ice calving or the other. Breaking off of large chunks of ice from a glacier. This process, also known as a cryosysm or ice quake, can generate massive amounts of energy-producing sounds that can travel over 5,000 kilometers. According to NOAA's description, the sound of ice calving can rise in frequency over about 1 minute and be of sufficient amplitude to be heard on multiple sensors. As you ponder this, you begin to consider the role of rubbing and ridging events within an ice flow where two or more areas of compacted glacial ice are forced together, inducing shear deformation and triggering horizontally polarized shear waves. Oceanographer Yumbo Xie explains that these events can produce sound in the failure sequence of an ice flow, similar to those emitted from a collapsing air bubble in a fluid. You start to realize that the bloop sound could be the result of such a process, and that it's not just a simple sound, but a complex phenomenon that involves the movement and interaction of large ice masses. You are standing at the edge of the South Pacific Ocean, where the icy waters stretch out before you. The year is 1997, and a mysterious sound has been detected by the U.S. National Oceanic and Atmospheric Administration, NOAA. This sound, nicknamed Bloop, is one of the loudest underwater sounds ever recorded, and it has sparked a wave of curiosity among scientists. As you delve deeper into the mystery, you begin to realize that the sound is not just a simple noise, but a complex phenomenon that involves the movement and interaction of large ice masses. Oceanographer Yumbo Xi's explanation of the sound's possible origin from the failure sequence of an ice flow has shed new light on the enigma. The scientific community, including NOAA's Christopher Fox, has been working to uncover the source of the sound. And by 2012, the consensus is that it is consistent with noises generated via non-tectonic cryosysms originating from glacial movements such as ice calving. The sound's profile, which rose in frequency over about 1 minute, is similar to those emitted by ice quakes, and its wide detection range can be explained by the mechanism of ice calving. As the mystery of the bloop sound begins to unravel, you start to appreciate the complexity of the natural world and the fascinating processes that shape our planet. The bloop sound, once a source of speculation and intrigue, is now understood to be the result of a powerful ice fracturing process, a reminder of the awe-inspiring forces that lie beneath the surface of our oceans.